Do you remember, okay, yesterday, started the Pythagorean theorem practice. In 1 and 2, you did Pythagorean theorem to solve for C. And I had you reduce the radical. So for example, radical 32 became 4 radical 2. Does it look familiar?
Yeah.
One from yesterday. And hopefully you filled in y and z as well, because these are isosceles. These are both congruent. And if there's 180 and you use 90, you would have 90 left and you divide by 2, and so they're both 45. Then you probably did this one, and you should have gotten 7 radical 2. So the reason I had you guys do these yesterday is because there's a pattern. Whenever this number is the same, do you see the pattern? What is it?
Oh, it's a ratio.
Well, they're in a ratio, a certain ratio. But yeah, this one, like, what's the? If
There's
these are both
2 sevens.
There's 2 sevens. So what's this? It's
7 and 9.
and so whatever the number is that was here goes there.
See, I did that.
That's why I had you do those yesterday, is because that's what we're doing today. The pattern from those is special right triangles. So let's talk about these. There are 2 types of special right triangles. That's what they're called. One is 45, 45, 90, and one is 30, 60, 90. This is referring to the angle measures. So they each are right triangles. And if the other 2 acute angles are 45 and 45, there's a pattern. 30 and 60, there's a pattern. Okay, let's talk about 45, 45, 90 first. On these questions, I'm going to say solve the triangle, and that means find the missing angles in sight. So if I say, okay, solve the triangle, you're like, solve what? Well, it means to find everything that you don't know, the 3 sides and angles. I'm first going to go to the middle here and show you how we get the pattern. I'm doing the general case of this. So I'm doing this, guys, but instead of numbers here, I'm going to do it when it's a variable. So this will work for any number. All right, so let me go back here. Okay, and so how do we get the formula for 45, 45, 90? Start with the square. Okay, start with the square. So draw a square. There's right angles. This is the middle of the page. Square has all sides the same. They're all congruent. And what you're going to do is you're going to draw a diagonal. Diagonal just connects the opposite vertices. Okay, we draw the diagonal, and what happens is there are 2 45, 45, 90 triangles that are formed. Because this diagonal, it makes 2 triangles. They're both isosceles. And I just talked about if they're isosceles, this is 90. The isosceles triangle theorem would say the angles are the same. The angles are the same from the isosceles triangle theorem, and so they must both be 45. So you draw a diagonal square, you get 2 45, 45, 90 triangles. I'm going to call one of the sides x. I don't know it. Yesterday in the practice, you called it was 4 or 7. It was given to you. And what I want to do is find the pattern to find C, the hypotenuse. So really, I mean, it starts off as A, B, and C. I'm just going to call it X, though, because they're the same. They're both X. A and B are both the same. So you could say A squared plus A squared, B squared plus B squared. I'm just going to call them X. All right, and then special right triangles. The pattern is formed from Pythagorean theorem. So I do one leg, x squared, plus the other leg, x squared, equals the hypotenuse c squared. And the goal is to solve for c. 1x squared plus 1x squared is 2x squared. So I can combine those like terms, and then I can do a square root to get c. So the right side will be c, the left side will be radical 2. Can't do anything with that. But radical x squared is x. And so that should look just like what we did in the practice. It was 4, 4, and 4 radical 2. This is x, x, and x radical 2. And so the pattern is the hypotenuse is x radical 2 times as much. This was so let's write that down. In this triangle, if you have a right triangle, angles are both 45, and we call one of the legs x, it's isosceles, so the other will be x, and the hypotenuse is x radical 2. Over here, I kind of sum up this diagram. It says the length of the hypotenuse is radical 2 times the length of either leg. Either leg. So on this one, you have a leg to go to the hypotenuse. It's times radical 2. And I should say this too, guys. Yesterday, for Pythagorean theorem, they gave you two sides. Maybe it's a leg and a hypotenuse. Maybe it's two legs. Okay. So with two sides, Pythagorean theorem. What today says is if you know certain angles, you could only have one side and find the other two. So you have less information about the sides, but if you know the angles are a certain value, you can find the other two missing sides. You don't have to do Pythagorean theorem. Let's see, so if you leg to hypotenuse, multiply by radical 2. And if you're going backwards from the hypotenuse to the leg, you can divide by radical 2. And I'll show you another way to do it as well. So before we try some 45, 90 examples, are there any questions in there I can clarify? Okay, so let's try. Next bit, here we go. Solve the triangle. So on all these below, we're going to find all the angles and all the sides. Simplest radical form, that'll come into play a little bit. I'm going to draw the diagram. You can just look above on your paper. All right, so as you can see, like 1A, well, we have a 90, a 45. We should get comfortable with the fact that if you have one 45, the other is also 45. By the way, let's say I didn't know, if I didn't know any of these, if even that wasn't 45, I didn't know, I can't do this. It's only if you know that angles are 45 and 45. Okay, so I can use this pattern. I only have one of the legs, but I can find the other two sides. Somebody want to raise their hand? Tell me what that leg is there in red. Brianna's leg. Brianna, go ahead. Yeah, because it's isosceles. What about the hypotenuse? Somebody else? Yeah. 9 radical 2. Thank you. So did you just look at it like x is 9 and just put the 9, just kind of move it over here? And in the pattern of the diagram, 9 radical 2. You could also take your leg and multiply by radical 2, and you get leg to hypotenuse 9 radical 2. It's as simple as that. These will not require hardly any work on these. On the next one, I'm going to go ahead and fill in here. Is that all right? The legs, sorry, I should put 45 and 45. The legs are the same, right? So 2 radical 2. So using the same logic over here, instead of 9, it's 2 radical 2. So the hypotenuse is going to be, 2 radical 2 radical 2. Really multiplying by radical 2.
Wait.
Yes.
If radical 2 times radical 2 is just 2, right?
Correct. We're going to simplify. That 2 stays the same. Radical 2 times radical 2 is radical 4. which is 2. That's a radical 4. And 2 times 2 is 4. Yeah, did you have a question? Okay. So this is what it is right here. Simplest radical form. So is this the correct answer? 2 radical 2 radical 2? Yes, but it's not in the simplest form. So square root of 4 is 2, and we had 2 times 2, and so it's 4. Hey, so sometimes students, this throws them for a loop for a little bit because they're like, wait, doesn't the answer doesn't the hypotenuse have to have a radical in it? No, this is just like the ratio. It's 1 to 1 to radical 2. It could have a radical 2, it most likely will, but since this one already was a radical 2, no, it doesn't have to. When we simplify, it's just 4. Next to, let me go and fill in the angles, right? We see a 45, so 45. I see a 45, 45. This one going backwards, I give you the hypotenuse. So I give you the hypotenuse this time for radical 2. Anybody want to raise their hand, tell me what the leg is? Thank you. Did you kind of look there? Did you look at this value or what? You look, yeah. You could sometimes, I think of it either as it's that value or you can divide by radical 2. Or maybe you just went backwards. You said it must be 4 because then this has to be times radical 2. Both legs are 4, right? Did you write down the other 4? Yeah, you did, right?
Yeah, I did.
Let's move on. So 4, I'm just looking there, and so the x is 4 in this one. Now here's a good one. What if this doesn't have a radical in it? 2 ways to do it. One, you could just know that it's like this. It's dividing by radical 2. I take the 6, how do you divide by radical 2? Here's what I've started to do a lot more recently, which I like. The hypotenuse, yes, it's the plural of hypotenuse. The 2 hypotenusi in the diagram and in my problem, they got to be equal. I can just set 6 equal to x radical 2. And then what I'm trying to find is one of the legs, which is x. And so I can divide by radical 2. So what I'm saying is if you just know to divide by radical 2, great. Otherwise set the hypotenuse equal and divide, and you'll get x is 6 over radical 2. Did you have a question? No? Now, I'm guessing last year, the year before, you were taught to rationalize these to get them so there's no square root on bottom.
Yeah.
Do you remember doing that?
I know I did it.
You remember the process?
I know I did it. So.
That's 6 over radical 2. Now, so first of all, yes, this is x. I'm not writing it in there yet because I want to get it in simplest radical form. But that is x. Okay. So does anybody remember how to simplify it?
Nope.
What? You multiply whatever the radical is on bottom, you multiply and divide by that value. Does it look familiar now?
Sort of.
Hopefully, no. So watch what happens. I multiply across. By the way, radical 2 over radical 2 is 1. So it doesn't actually change the expression, just how it looks. It's still equal. You multiply across, and you get 6 radical 2. And on bottom, there's radical 4 again, which is 2. And finally, you divide the 2 into the 6, not the radical.
Are we going to do like plus and minus this year?
Just the 2 into the 6, and you get 3 radical 2.
I remember this. We did sometimes we do like 4 plus or minus. Like
That's quadratic formula.
Oh.
We won't do that.
I remember that.
Next year you will. Do not divide the 2 into the radical. Now, if they said round, watch this. If they said round to the nearest tenth or something, well, you could have just stopped here, right? So you had 6 over radical 2. Just put it in your calculator. No need to rationalize. You could if you want. Okay, I have one other thing to show you about this shortcut. 6 divided by radical 2. Here's the shortcut for these. Divide by the number inside. 6 divided by 2. Then write the radical, the whole thing next to it. It's as simple as that. So, watch this. 20 divided by radical 5. What would that do?
4.
20 divided by 5 is 4.
Radical 5.
And then you put the radical 5 next to it.
Oh.
Isn't that a little easier than the rationalizing thing?
I actually like
Crazy.
that.
So, like, here's an 30 here divided by radical 10. 30 divided by
Radical
10.
10.
Yeah. Do harder. This is fun.
There is nothing harder.
You should give us worksheets and do this. This is fun. Yeah.
So that's 45, 45, 90. Anything else to clarify on that before we do 30, 60, 90?
No.
Not too bad. 30, 60, 90. Flip to the next page. Yeah.
So what if when you bring that you can't you can't do division
Oh, if it was like that, you still divide. So guys, here's a good point. What if it doesn't come out evenly? I think that's what you're asking. You still can divide. 5 divided by 2 is 2.5, and then radical 2. It just will be a decimal
Oh.
or a fraction, but I prefer decimal. This still works. Good question. 30, 60, 90. I'm going to go right to the middle of the page and show you why it works, what the pattern is. Let's develop it. Derive means come up with the formula. How to derive 30, 60, 90? You start with an equilateral triangle. An equilateral triangle has 60-degree angles. They're all 60. Don't draw the top one in though, because what I'm going to do is draw at an altitude. Altitude. And altitude. Guys, listen up. Altitude is perpendicular. It's the height of the triangle, perpendicular. So it makes a 90, it makes a 60, and a 30. We haven't done it yet, but if you subtract 90 and 60 from 180, you get 30. I'm wanting to work with the right triangle. You could work with either one. I'm just going to do the right one. What I'm going to do is the side I really want to start with is the short side here, the short leg. I'm going to call that one X. If that's X, what happens is this over here would also be X. So the whole side in the equilateral triangle is 2x. And if this is 2x, that's 2x, and this is 2x. The equilateral triangle, all 3 sides are congruent. And what I'm going to solve for is the altitude. I'll call it b. So here's what I end up with. X, 2x, and b. And again, I'm going to do Pythagorean theorem. So we have 2 of the 3 sides. I just need to find the 3rd one. And I can do Pythagorean theorem. So I have one of the legs x squared plus one of the legs b squared equals the hypotenuse 2x squared. Notice I put that in parentheses. It's not just x squared, we're squaring the 2 as well. Girls, please listen up. X squared here, and then b squared here, and I'm going to go ahead and square the 2x. So 2 squared is 4, x squared is x squared. If you don't put the parentheses in, then it actually throws off the pattern and won't work. So you do have to square the 2. So I'm solving for b, so I'm going to subtract x squared. I'll get b squared here, and then 4 minus 1 is 3x squared. And just like the last one, I do a square root, and we'll get b on the left. Square root of 3 is square root of 3. X squared is x. And we traditionally write the x first. So what we just found, in the 45, 45, 90, the main number is radical 2, x radical 2. The 30, 60, 90, it's x radical 3. Again, just Pythagorean theorem. Bx and then 2x is the hypotenuse. So let's go back here and write it down. I'm going to put the 30 at the top here, the smaller angle. The x was the one down here, the hypotenuse was 2x, and we just solved and found this one's x radical 3. Okay. Again, this just kind of summarizes the box here in the paragraph. It just says, in 30, 60, 90, the hypotenuse is twice, 2x, twice as long as the shorter leg. X is the short, 2x is the hypotenuse, that's double. And the length of the longer leg, this one, x radical 3, is radical 3 times the shorter leg. So in these problems, it's very important to get the short leg, because that's the one. There's a more complicated way to get from these two that we're not going to do. Okay, so really, if you have the short leg, you can immediately double it to get the hypotenuse, and radical 3 times as much to get the leg, the long leg. I summarize that over here. Find the short leg first, short side, short leg. And then this just says going between the short leg and the hypotenuse, you double it to get the hypotenuse, or if you have the hypotenuse, you divide by 2, take half of it to get here. And then it says radical 3, same thing, short leg to long leg. Okay, I think we're just going to try some of the examples at the bottom. So, any questions so far then? Sounds good. All right, so let's go to the examples. Simplest radical form again, we'll solve the triangles. Some of them already have 30, 60 filled in. That's good. Over here, 90, 60, 30. Okay, I always like to highlight the one that I need, the short leg. This one, it's 5. I already have it. Okay, so pretty simple. The hypotenuse, x to 2x, in this pattern is double. So I'm doing, really, x is 5. Right, x is really 5. So I'm doing 2 times 5. 10. And again, x is 5, and so I'm putting 5 in right here, 5 radical 3. It's as simple as that. Make sure to, sometimes students mix these up, put 5 radical 3 as the hypotenuse, so that's, the long leg is radical 3. Hypotenuse is double. In B, this one, so I outlined the short leg, that's what we need. Hypotenuse is 14, so I have this one, and I just need to go here, and it's half as much, so it's 7. Okay, again, I'll show you as well, like if you want, you could set the 2 hypoteni equal. Divide by 2 and say x is 7. Okay. And then same as last one now that we have the short leg, the long leg is radical 3. So we have here to here, 7 and 7 radical 3. And let's finish up with C for this group. Okay, C is we have the long leg. The long leg is the one opposite 60. We need the short side. So long to short, here's what I like to do on these. Set the long legs equal. The 6 equal to the x radical 3. If you already know the pattern and you just know we're going to have to divide, that's fine. If I set the long legs equal and I solve for x, I just divide by radical 3. And so here is where way, this x is really y over here. In the diagram, this is x radical 3. I'm solving for this one though, which is y. 6 divided by, I'm doing the shortcut. 6 divided by 3 is 2, and then I put the radical 3 next to it. So 2 radical 3. Okay, and then hypotenuse, once you have the short leg, the hypotenuse is double. I only double the number, not the radical 3. So it's 4 radical 3, not 4 radical 6. Let's see. Okay, I'm gonna skip D, I'm gonna do E below. And then I'm gonna do two quick word problems. Any thoughts on this one though? These three? It's just a lot, getting used to the pattern. Yeah. Once you guys practice a little bit, it's going to become natural. Hey, I didn't say this yet. The good thing is these diagrams are on the formula sheet. So you do not have to memorize these 45 and 30, 60, 90 patterns. I'm going to do E. I like this one combines both the patterns. So I have a 45 down here. I can fill this in as 45. A right triangle with 30, so I can fill this in as 60. I'm solving the triangles, and all I have to start with is the 12. Okay, that's what I'm starting with. They'll pretty much only give you one of these. I gotta do the short leg, which happens to be x. That's the hypotenuse, and so this one is half, it's 6. And then long leg, 6 radical 3. Okay, now I need to jump back to 45, 45, 90. The pattern is x, x, and x radical 2. And so both of these are just 6 radical 3. Because it's isosceles. And the hypotenuse, here's another one of these, where my x already had radical in it, which is fine. It's 6 radical 3 for x, but then radical 2. And that is 6 radical 6. Sometimes that will simplify and be a perfect square. You can do more, but other times it's just going to be like that. That's the simplest form right there. That one combines the 30, 60, 90, and the 45, 45, 90. Okay, flip the page, and I'm just going to finish up with 2 quick word problems. So you can see a little application of these. I really like the first one. It's baseball, softball related. So if you have either, let's see, they call it a diamond. It's really a square. So if you play softball, softball or baseball. This is home plate. So in baseball, it's 90 feet between bases, and softball, it's 60 feet between bases. So this one's softball. How'd my square turn out? That's not great, but
Here's mine. It's okay.
it's.
I have like a squiggle. It's okay.
I like drawing from the side. I can't line it up very well. Well, it's a square. So squares have right angles, and all the sides are the same. They're all 60 feet base to base. You notice too, I'm very visual, so I like to just draw a picture. Almost the first thing I do, just so I see what's going on. The distance base to base is 60 to the nearest foot. So we're going to round. How far does a catcher throw it? Catcher's at home plate. Catcher throw it from home to second. That's a diagonal. And what I haven't written in, remember when I draw on a diagonal in a square? That it's 45, 45, 90. And we kind of already knew that because they were both 60, right? Isosceles. So those had to be 45. So without doing any work, because I could do Pythagorean theorem on this one. I actually have more, there's actually 2. I could do Pythagorean theorem. That would work. But why would we want to do all that work? Someone want to raise their hand and tell me what it's going to be? No extra work needed. Somebody else? Charlie?
60 radical 2.
Thank you. Yeah. Just the 45, 45, 90 pattern. The nearest foot, So this is where you would put it in your calculator now. So somebody's doing that. Okay, you got it. To the nearest foot, you got it? So you're putting this in, 60 radical 2.
84.
So rounding up, because it says nearest foot, about 85 feet. So a lot longer than home plate to first base. Almost 50% more, almost 30 more feet. 85 feet, nice little problem there. Let's do one more to finish up. This time, so I'm also showing you, anytime you see a square, they could make 45, 45, 90 out of it. Anytime you see equilateral triangle, they can make 30, 60, 90 out of it. So this one, an artisan is making pendants. So these are going to be smaller, but 18 millimeters is going to be the height. They're going to be equilateral triangles. And the height, or the altitude, of each one is going to be 18. I didn't draw on the 60 at the top, the 60 degrees, because my altitude will split it into 30 and 30. So there's the height. What is the length of each side of the pendant? So like this side, or that side. So you gotta think, I have a 30, 60, 90. There's not, so sometimes students want to directly go to a hypotenuse, but there is, but it's more complicated. So just go directly to the short length. Look back at the 30, 60, 90. It's the x radical 3. So I'm going here to there. This is the type I like to just set the long leg equal to the long leg in the diagram. 18 is x radical 3. And divide by radical 3. If you immediately knew just to divide by radical 3, fine. You don't have to set up an equation. So 18 divided by, I'm going to do the shortcut. 18 divided by 3 is 6. And I put the radical 3 next to it there. Then I can double it to get the hypotenuse. 12 radical 3. So that's the length of each side. What's the length of each side? 12 radical 3 for this one, and the bottom one here also 12. It does say the nearest tenth, so I kind of forget this one. Was it like 18.2 or something? 19.2? Somebody do 12 radical 3. 20, no, I was way off. 20.8. Okay, I'm going to stop there, but that's it for special right triangles. You see a little application of each. And there's two diagrams, and you don't have to memorize them. They are on the diagram, which is nice.